So this is a quick review of the math involved in today's lab, where we had our 3 points, point A, point B, and point C, and we did a traverse, starting at A, going to B, going to C, and back to A. And then the second phase of the lab, we set up at some spot with our instruments, and we topoed in A, B, and C from benchmark. So let's take a look at those, and we'll go through the math real quick on all this. So I'm just taking one groups of data right here, and so we have from A to B, 155.09, an angle of 28, 18, 15, and then we had from A to C of 108.71, of 306, 39, 00. And notice one of your groups found out that hard way that this is relative. When you turn it on, if you don't set a 0 on those Sokiyas, it sets a 0 point relative to its base plate. So its 0 direction is set up relative to its base plate. If you don't define where that is, it picks a 0 point for you. What we were interested in was the difference between these. And so that's what we were looking for. We weren't looking for the actual, what was truly directional. So from that standpoint, we have these right here. When one group set up from A to C and then turned off the machine and went over and tried to do A to B, they got completely screwed up because it lost that setup point, that relative 0 point for the horizontal angle. So let's do B to A. And so for their B to A was 154.99 at 160.13.35. And we have 175.97 at an angle of 197.54.30. C to A was 108.65. We have 145.22.55. I think that's 27. Handwriting sucks. And 176.00. All these are to 2 decimal places, so you can come in here, format cell, number. What is it?
22 minutes at 27 minutes. No, it's 20.
That's 27.
It's 27.
It says 27. There's a line through it. That's why I didn't see that line. I only noticed that because 176 had a line through it also. At 84.47.05. So the first thing to look at, the horizontal distance of A to B should be the horizontal distance of B to A. What is our difference? So A to B versus B to A. Let's put this down here. Insert. So they should be exactly the same, right? So plus that minus this, we're off 1/10 of a foot. From B to C versus C to B, plus B to C minus C to B, we're off 3/100ths, or 3,000ths, or 300ths. And then A to C versus C to A to C minus C to A, we're off 0.06. So that's our magnitude of error in terms of our horizontal distances between the reads, back and forth. Not great. I would not say that you guys would get your surveyor's gold star today, but for your first time doing this, pretty dang good. So congrats. That is relatively close. Let's check the angles now. So this is in degrees, minutes, seconds. Home, coming across. Now I want this in decimal degrees because I want to be able to calculate this a little bit easier. So decimal degrees is plus the degree plus the minute divided by 60 plus the second divided by 3600, 60 times 60. So there's our decimal degrees values for all of these. And now the difference is going to be plus this minus that, plus this minus that. And if I were to do that here, it would be plus this minus that. But is that really what happened? Do we really think you turned 278 degrees out there? The answer is no. What really happened is you start off at 306. So what's happening here, this is 306 to 28. And this is something you got to look out for when you're doing relative. So you started off on your coordinate system. Remember, these are measuring azimuths. So you started off, this is 0, 90, 180, 270, back to 360. So relative to the plate where you set up, your first read was at 300 degrees this way. Whatever it was, right? 306 or whatever that number was. Your second read was right here at 20 degrees, right? The interior angle wasn't this distance. If I subtract those two, that's what I would get. The actual read was in here, right? So that's what you actually read. So if we look at that, there's a couple ways you could do that. You could say 20, which is this distance right here, plus this distance right here, which is 360 minus 300, which is 60. So 20 plus 60 would have given me 80, right? Do you see that? Or if I took 300 minus 20, I get 280, right? On that outside. And if I say 360 minus 280, I get my 80 degrees. Because I just want this interior angle right here. That's what I'm looking for. Does everybody see that? You can get two different ways, but physically, you should be able to see this in your mind now from that field. So, we don't want that large angle. We really want plus 360 minus that, and that interior angle was 81 degrees. Does that make sense now, looking at that? So, this is my interior angles that we measured. And what should those add up to? At some. It should add up to n minus 2 times 180. So, interior angles, the summation of your interior angles, right, is going to equal n minus 2 times 180, because we have three sides. So 3 minus 2 times 180, so it should add up to 180 degrees. So if I have 5-sided traverse, it'd be 5 minus 2, which would be 3, times 180, would be the addition of all the interior angles. So if we look at that, summation of these equals 180.0167. That's pretty cool. So we say that minus 180. So this is my error, right? In degrees. My error in minutes would be plus that times 60. So I'm off by, really? I guess I'll have to accept this data. You're off by your 1 minute allowable. So, nice job, team 2. You actually came in respectable. Even with Kelly stepping up over the wrong point. So, Very nice job setting up the equipment, and you see how you got within the tolerance we set for this class. Does that make sense? Any questions on that? So we know this error, then we'd have to divide into these angles, right? So we know we're off 0.01667 degrees, right? So if I add up all my distances, so A to B is plus A to B plus B to A divided by 2. This is my average distance. Plus B to C plus C to B divided by 2. That's my average distance right there. And plus A to C plus C to A divided by 2. That's my average distance for my total at sum of that, right? So this is my total distance around my traverse. And this is the length of each side. So the amount we're going to propagate right here, our error adjustment, is going to be equal to plus my error, my total error, right? Times for A, that length, divided by, plus, I want to propagate this through, so it's going to be plus that error times that divided by my total, plus that error times that divided by my total, and plus that error times that divided by my total. So you can see how I weighted the error, right? This length right here was 81 degrees. This angle was 81 degrees. So it got more of the error adjustment, a weighted average. Does that make sense? Because this had a bigger angle, right? Because this angle is bigger than these two, it got more of this error propagated through it. And since this was higher, this number was higher, I have to subtract my error adjustment to get back down to, so my adjusted angle would be plus this minus my error. So those are my adjusted angles. And now when I add those up, I get back to exactly 180. So I've weighted the error and propagated that through each of the angles. Does that make sense? Any questions on that? So we have our adjusted angles, and now we got to figure out our lengths. So these are our average lengths right here. These are our adjusted angles. This is a weighted average of 2 points. Take 1, 2, add them together, divide by 2, you got your average. So we have our average lengths, and we have our average adjusted angles. That would produce our topo map. So to go from A to B, this would be my angle, and then I would turn this angle to go to B, and then I go from B to C, that distance, turn that angle, go that distance, turn that angle, I've reached back to A. Does that make sense? Any questions on that? Part B was our topo, right? And let's see how this compares to our topo. we have a setup of benchmark of a length of 119.41, and we have a degree of 228, 59, 30, and then I have 94.34, 249, 4408. I have a setup B of 88.47 of 133.402, whoops, 43, 133, 40, 25. Setup C is 88.05, 322, 46, 45. I want to get the angles right here. And because we ran into rain, they weren't able to get the actual setup back to the benchmark. Because they did so well, we're going to assume they were close. Just to be nice. We don't know that for sure. It would be nice to have that benchmark in, team two. It would have been really cool to have that benchmark, because as a real survey, I can't take this data. If you don't tie your data back to a benchmark, I can't accept the data, because I don't know if you actually closed it or not, or if somebody had their hands on the tripod too much. Right? So, I don't know if I can accept this or not, but we're going to assume these numbers are correct. And let's take a look. So here's AutoCAD. Now I'm going to come in here and take the grid off. I want the grid off, thank you. I never draw on the zero layer, so I'm going to say topo survey, make this current. And I'm going to assume 0, 0 is my setup point. So my setup point is going to be at coordinate 0, 0. I don't know any better. We're going to just put it 0, 0. Now, the state guns that you used measure in what? Cartesian, azimuth, or bearing. Those measurements were at what angle? Cartesian, azimuth, or bearing? No. You're down to 2 guesses. Azimuth. It always measures in azimuth. It starts at 0, right? It starts at 0 and goes clockwise. Cartesian starts here at 0 and goes counterclockwise. Azimuth start at due north and goes clockwise. That's how it sets it up. That's the surveyor's language, is azimuths. They're not Cartesians. Why? Because surveyors like to be backwards. And they like to use big fancy words. 2 things that sets a surveyor apart from other people. So, let's go back and look at our AutoCAD drawing. So if I were to draw a line from right here, I'm just going out this way, right? And then I rotate this line from right here, at this point right here, I'm going to rotate it 30 degrees. Which way does it rotate? It rotates counterclockwise, because AutoCAD's set up in Cartesian coordinate systems by default, not in azimuths. So angles and everything is in Cartesian. So, in order to get AutoCAD to change to a base, you got to come into Options. Actually, let me do it this way. I think I still can do it this way. If I go into Units, and I say decimal degrees, except I want to go clockwise with my rotation, right? And I want degrees, minutes, seconds, because that's what we're doing it in. So I'm going to change it to degrees, minutes, seconds, position 0 degrees clockwise. Direction, my base angle is going to be north. So my base angle, my straight line, is north. That's how we start in azimuths. Does that make sense? We're not east, we're north. So I say okay. And say okay. Now if I draw a line from 0, 0 at 10 at an angle of 0, right? I go straight up. And when I rotate that from this point right here, and I rotate that 30 degrees, right? It rotated the correct direction. So I got my directionality of north set at 0, and I'm rotating clockwise. And both of those were found by typing in the word units and changing your angle type. So we're going to set up, and I'm going to assume that 0, 0 is where my gun is set up, right? I'm just going to key these in. So I've got a line from 0, 0 at a distance of 119.41, an angle of 228 degrees, 59 minutes, 30 seconds. And right here is where that was. Now, our gun was not set due north. So this is relative, right? But it's not really that far off as it turned out. Because from where your HI was set up, where was your benchmark? It was almost due south, wasn't it? It was a little off of south. It was actually almost in that direction, which is kind of cool. But that's where our benchmark would be. So I'm going to draw a circle right here at the end of this point. I'm going to do text, dtext, right here, this height. I'm going to say benchmark, benchmark. Right there's my benchmark. And now I'm going to draw a line from 0, 0 to my next point, which was 94.34, and an angle of 249 degrees, 44 minutes, 08? There is no 08 on that gun. It only measures to the 5 seconds. So we'll say 08 because that's what's on it. But but it can't measure to 08. So right there, and I'm going to circle the end right here. And I'm going to copy this from here up to here. I'm going to DD edit. And that's point A. Then a line from 0, 0 to 88.47 and an angle of 133 degrees, 40 minutes, 25 seconds. And I'm going to copy this and this from the center of here to the end of right here and DD edit. And this will be B. Move. And then,
if it only does, like,
go ahead.
those seconds, every 5
Right.
and 10 and 15, 20,
That's the old gun, correct?
is that, does that affect the accuracy at all?
Yes, it does.
Because I was gonna say, that's kind of a big gap when you're talking that many seconds on a map. Like,
The further you go, that's where these guns had their limitations. Right, the Sokiyas that you're using had limitations on how far they could shoot
Yeah,
because of that error. 805, an angle of 322 degrees, 46 minutes, 45 seconds. And we'll copy this and this from the end point right here to the end point right here and DD edit. Make that C. So then layer property, come in here, create this, This is our traverse. Main layer, traverse. And we'll make this hot red. So right here is our stuff, so I'm going to draw a line from the end right here to this. You can do center too, center right there, to the center right there, to the center right there. And we're going to copy this over to right here, right? And now I'm going to say distance, distance, distance. What in the world? Okay, fine, list. So, the length of A to B was 155, 1152, and let's see what we got on our traverse. So that's what we got, 155.04, 155.12 when we did our topo. From B to C, list. So B to C was this. B to C, 175.98, we got 175.96 according to our topo. And we come back here, C to A, Control C, back to here, 108.68 versus 108.66. Like I said, you're still not going to get your survey merit badge, but these are pretty good for your first time out there. For your first time, considering all the stuff that was going on out there, doing it two different totally ways. One, a traverse, where you set up over top of each point and you get the angles relative, versus a topo where you shot each point and you post-process that. Not too bad. You guys may actually may give you a gold star next week. Maybe.
Maybe still do it today.
So I have a question, like on that, when you're holding that stick, the pole,
The rod,
and
Thank you.
you have to keep it level with that,
the bubble,
how important is that? Like if
huge.
So like if
You
it's
did
not.
can't like that, you're at a distance, can't be other
Right.
way towards you.
Right. You could be off. That's part of your
Like,
propagation of
so when I'm
error.
standing there like that whole time, I'm just like standing there trying to keep it right there. in the
Yes.
center. That's what I have to do.
It's vital.
Because I didn't look up or anything, people
No.
had to yell at me.
Correct.
Yes.
We would have yelled at you.
So that is really important.
That's
just to make
very
sure,
important.
Like you're holding
Yep.
it right there. Okay.
Just like when you go out and if your gun is on a 12-degree angle, like one of your groups set up, and I looked at that gun and I'm like, whoa, that really sucks. You can't have your gun at a 12-degree angle either. Your gun has to be vertical. Your rod has to be vertical. All that's critical.
Like when you have your survey points, do you have to have it right over the people that are looking down?
But let's do one more thing now, since we can do this. And that is dimension, angular, except I don't want that. I want there we go. Modify. Primary units. And my angle is set to 0. I'm going to give this, and I want to go degrees, minutes, seconds, like that. So I changed my primary units and my angular dimensions to be degrees, minutes, seconds. And let's see what we got. So I dimension my angle from here to here. 81, 37, 58. Oh, we changed it to decimal degrees. Okay, fine. Delete. Dimension annotation right here. Modify the standard. Primary units. We'll go back to decimal degrees and we'll go 4 degrees. Say OK and close. And so now when we do an angle from here to here, 81.6329, 81.6329, 81.6329.
You got 92, you got it.
29 versus 81.6466 that we measured, right? Let's go back and we'll check the next one. Angle B from here to here. 37.6590, 6590, 37.6590 versus 6785. Did I get that right? I don't even know if I made 659 and 659. Yep. And finally, C. Angle from here to here. That is 60.7081. 708. And if I add those up, I get 180 also. So this is the difference that we got from our topo measurements versus our traverse measurements of the exact same points. Those physical points are out there in space. Those are fixed out there in space. We just measured them 2 different ways. And we got relatively, like I said, you guys aren't survey grade yet, but you got really, really close for your first time between the 2 measurements of figuring out where in space these points are right here, which is really cool. So you did a traverse right here, and then you did a topo, right? And we got those values, which was pretty close. You can see right there, right there, right there, and our lengths right there, right there, right there, between the 2 methodologies. Pretty close. Any questions on that? Any questions?
Right now,
Go once, going twice. So you got to see it both AutoCAD, you got to see it numerically in Excel, and the whole concepts. Cool.